Hello and welcome to the first lesson in the NR 566 Natural Resource Inventory and Data Analysis course. Each of these lessons is structured to take about 15 to 20 minutes and will always start with a slide pointing you to relevant reading material and typically a YouTube video to help reinforce some of the lesson's ideas. Modules will either have one or two lessons depending on how strongly the reading material is needed to support the lesson. Should you have any questions that might normally be posed during an in-person lecture, please post them to the class coffee shop and be sure to reference which lesson your question is about. We're going to spend the first few weeks of the class reinforcing some basic statistical principles that most of you should have been exposed to during your undergraduate studies. The first lesson is going to reinforce the ideas of why we must sample in order to understand natural populations, and will also lay the basis for the terminology we will use throughout the semester. There are very few decisions we make in natural resource management that do not have numbers reinforcing the decision. I believe that Lord Kelvin may have said it best, that when you measure what you are speaking about and express it in numbers, you know something about it. But when you cannot measure it, when you cannot express it in numbers, your knowledge is of a meager and unsatisfactory kind. Often as resource managers, we are challenged to make decisions about competing resources and objectives. In an ideal world, we would have two ways of collecting the data we need to make decisions about, either through a census or samples, where a census is a complete enumeration of a population where every unit is considered in describing the population. Ideally, we would use a census when trying to make management decisions. However, financial, logistical, and time constraints typically limit this option. Because of these limitations, we must make decisions based on what we know about a subset of a population. We call this a sample or partial enumeration. Our goal when drawing a sample is to select units that adequately represent the population. This sample then allows us to make general conclusions about the population. One way to think about this is if we want to know the average size of Gambel oak trees within a management unit, we run into an issue. Since Gambel oak can grow at densities of more than 10,000 stems per hectare, measuring every tree for a census becomes unfeasible, leading us to perform a sample to inform our conclusion about the average tree size in the population. As we move through this course, we will be looking at a wide range of methods we can use to sample natural resources. My hope is that our discussion will help you answer the basic questions of which method is right for my objectives, what assumptions does my method require, how efficient will my method be compared to other approaches, and how strong are the inferences by collecting data via this method. Now we're going to spend the rest of this lesson putting us all on the same footing with the terminology we will be using. We are going to take a look at the following terms to help us define the population we are looking at and draw conclusions about it. The first concept we need to cover is the term statistical study, which is a common way of referring to a process that measures things to produce numbers. These measurements can be anything we quantify in natural resources, from the diameter or breast height of a tree to the number of eggs in a nest. Now let's look at the term sampling, which is used when referring to the process of drawing conclusions about a population from only a sample. This term carries certain connotations behind it about the inference, precision, and confidence we have in our conclusions based on specific properties of the design used to collect the samples. The samples themselves are simply the set of values we collect from a population. The frame in a statistical study represents any bounds we place on a population to define it. Commonly, when working in natural resources, we call these frames either a stand or a management unit. When we try to characterize a population, we must define how information will be structured or summarized. When we do this, we define the sampling unit, or the subsections we divide the population into. The sampling units we actually collect information from are what we draw our conclusions about the entire population from. These sampling units are often referred to as experimental units, physical units, or plots. We define the sampling units based on what we want to learn about a population. In forest inventories, this could range from measuring individual trees to measuring entire stands. While in fuels management, this could be a single Brown's transect to the collection of several Brown's transects at a single location. When we consider all of the possible sampling units as a set within our frame, we are looking at the entire population. We also commonly refer to this as the universal set. When we define this universal set of sampling units, we define the first parameter of a population, which is big N, or the number of sampling units in a population. These universal sets could represent all of the diameters at breast height for measurements of trees in a stand, or the length of each rotten log within a watershed. The universal set has a specific relationship to our sample, which represents the sampling units we actually collect information about. This could mean that we count the number of eggs in 5 nests within a stand. Then these 5 nests would represent our first statistic, or little n, which is the number of sampling units actually measured. When we describe the characteristics of a population, we are using parameters such as our big N value. The aim of sampling is to measure a representative sample of the population to obtain a reasonable estimate of your parameter. These population parameters are considered fixed, generally unknown, and only changing when the population changes. The first we will look at is the population mean, which is the summation of all possible sampling units divided by big N, or the number of sampling units in the population. The second is the population standard deviation, which describes the average variation of the samples from the average sample value. The numerator under the radical is called the sum of the squared deviance, and the denominator is our big N value. When we are only summarizing the values from our sample, we are producing sample statistics. These values are estimates of the population parameter. The first statistic we will look at is the sample mean. Note that the only difference within the formula is that the little n is substituted for big N. The second is the sample standard deviation, where again the numerator is the same other than little n being substituted for big N, but now the denominator is little n minus 1 instead of big N. This is because we have to account for the fact that we know less about the population. An important thing to remember is that Greek letters are used when referring to population parameters, and Roman numerals are used when referring to sample statistics.